base as open robot. Uh, the other thing, the bigger, what's not identical is bigger down part because there is a bigger ball and a bigger plastic ball and even it hasn't got ultrasonic sensors because it wasn't the time and it, what's new this year is this sensor. The sensors are from are replacing all the infrared sensor that was high technique infrared sensor. That is this and these sensors numbers and these have got a chip microprocessor which sent to the Arduino only number of sensor what can go the best. Yes, 0 is it's not sensor. All are 0. And this is the robot and the compass. It's identical too. This is a high technique compass sensor. And here is camera, open robot star. This camera Pixel 2 and here is Pixel Lab. Batteries are the same too and that's all.
Thank you. Are there questions?
I saw that you're using the screen to like change some variables.
Screen is it this robot the camera set only by computer and it all as compass color sensors and the other things we can change by screen and buttons. But sometimes when we turn off the robot, the buttons don't reacting, and it's open to press button, but it don't do anything because it don't react sometimes.
All right. Thank you very much. So now team Auto Prikratki, right?
Yes. So,
So your team out of okay. We come from Varas and my name is Juraj, this is Franco and this is Viktor. So these are the robots, they're almost the same from like last year, but we added some changes to the design of the whole robot. And the most important part for this year was to improve the strategies on the field, because the construction is like really good. It doesn't have any flaws, and Franco was more constructing the robot than me. I was mostly the programming part, and so we can tell you more about it.
so from last year, the biggest design change is that we went from a circle to a square design. It was mostly so we would stick out every single robot. Here is circle, we're square. So, and it also helps in the situation that this happens. So he will push him with 100% power. When there's a circle, he may move. So last year we had one PCB. It was circle and it was too large, so we upgraded to this smaller one. For the wheels, we had a four rubber wheel design. For this year, we've tried two designs: one with these rubber bands from silicone and these which were bought, and 5 of them. this proved to be better. The performance was the same, but these wheels got too jammed up by the grass. So I think we will continue with the black rubber. You can see one failed during the last match. That's one of the flaws. So the thing we need to improve on the wheels is the structural integrity of the the pos- the the place around the rubber rollers. Uh, for strategy, first off, Yoga will continue. So this was our goalie, and he proved to be a better striker, even than the original striker. So Yoga can continue on that.
So, Franco forgot to mention, we decided to add
Oh, yeah.
a manual kicker. It's just an
A spring from a
spring, yeah.
trampoline.
So when the robot like gets high speed and bounces the ball like very across. And also the cool thing about this, if we put it like we firstly made this so it doesn't fall down entirely, but before it had it fall down, and basically
could kick
the
up
robot
the
could
wall.
kick it up a little bit, and it was quite impressive.
Maybe in open it would really kick it
Yeah.
in the air because the ball is really small and very
Why
light.
did we decide for a manual kicker? Because we had problems. We had problems like putting a solenoid on the robot because we had problems with crashes on the TC, and we didn't know how to fix that problem. So
I got the idea for a manual kicker, which
Yeah.
no one has ever done.
and also we tried first, like he said, to make a goalie. Like this was the main thing that we tried to do. We didn't even focus like on the striker, and it worked like quite well. But
In the first match, it proved to be that we weren't aggressive enough, so we decided to turn him into another striker, and he proved to be better. than,
basically, the problem is if this robot goes out of bounds, there's no one who can attack the ball.
and he was a lot of the times alone on the field, and that was stupid. Maybe in the future, when we get better ultrasonic sensors and we can improve and maybe improve on communication, so he knows he's alone, he turns into a striker, we can do that. Or we can, like the limit for him was around here, he couldn't go further because of the wall. And if we had better ultrasonic sensors, he could go to the other side
Those are
of the
just
field.
done in basic Arduino SRC sensors, so they're quite bad. And yeah, we have 4 joint max motors on the robot. They're actually not quite as good as we expected because they waste a lot of power.
They're
So-
strong, fast, but they waste a lot of power. That's the
So
downside.
basically, like one battery doesn't like last an entire half. But even when the halves are like 10 minutes, so we need to change the batteries
Every halftime.
Yeah.
But we manage. They're very strong, but we need to improve the line avoiding, and when we do that, we can speed them up and really get 100% from
And
the
also,
motor.
we created our own PCB sensor here. It's like 32 LEDs and 32 AF sensors. They're just connected to one multiplexer, so we get like 6 pins at all. 2 pins for like controlling them and 4 digital ones.
One more thing, we've made a system where if the values aren't where you want them to be, let's say when you try to locate where the ball is, 0 is like here. We've made a system which we didn't use, we didn't need to, but for so like here you can unscrew it and then you can turn the sensor, and then this diode will like be here and this one will be here, so you turn them for a few degrees and you move your 0 to here, and then you have the perfect
It's basically like manual calibration.
manual calibration. Yeah,
And yeah.
that's basically it.
Yeah. Very nice description. Thank you very much.
Any questions?
Any questions for Tina Sofigati?
Oh,
Right. Let's continue with the team FC Benchwarmers.
These are 2 robots. We have one big PCB, which is basically all the electronics on it there. There's DNC regulators, motor drivers is here, so that wires don't go up and don't affect the sensor. Here we have line sensor, which is the same as autoclick kratky. This was made last year in a collaboration that was for
The World Cup.
World Cup in France. This year we made our own dual line sensors, but we had problem with LEDs and resistors, so we didn't have time to change them and use them on this. Here in Slovakia. This competition had a lot of problems because we didn't have much time to improve our robots. We had problem with special line sensor here. Unfortunately, this one does not work anymore. We have to see why it doesn't not work. We also had problems with both sensors. They didn't really the angles that they produced, like they weren't really right. But in the end, we managed to make this robot work, which is the main goal. So in the future, we can improve that.
So basically, the biggest problem we had is the line sensor, which you also mentioned, and this IR sensor died. Basically, it was good at reading values. So from the last year, we switched up by having our own PCBs. This one, okay, this is partially collaboration, but this is like our main PCB. Last year we had like multiple segmented PCBs with S32 instead of TNC, and we used a system called CAN bus, so to communicate between parts. So we can see that this one is also analog and CAN bus compatible. It has this special connector, and the thing with CAN bus is that it's quite a proprietary.
Yeah. No, dobre, Goran.
I have a retainer, so it's harder for me to speak. It's proprietary, and it works fine, but there are a lot of libraries that really lock you into that ecosystem. So we wanted to break free from that by having our own driver logic and everything. That took a lot of time to figure out, because we need to optimize functions so that it could work similar to before, but with our own logic and stuff. Because we have a system of splitting the robot into basically two. We have 0 to plus 180 and 0 to minus 180 instead of 0 to 360. And and it took a lot of time to figure that out. As well as we burned a lot of these sensors, and when this one failed, we didn't have any replacements. Any questions?
Any questions for the team? Benchwarmers. Do you use any communication between these two products?
Not right now, in the future maybe. We have this ultrasonic. Right now we're not using them, but we want in the future, when we have the camera and dribble on the robot and kicker, to also have a goalkeeper and attacker and communication when one goes out, so the goalkeeper can become an attacker. But it doesn't happen in the future. We now go step by step.
How did you make these rubber parts?
This is also same as this one.
Yeah.
So we bought already built the wheels and just took these ones off and put them.
Okay.
All right. If no other question, I thank you. We have only 12 minutes left, so please, each team 6 minutes.
Okay.
Now the team XLC capture.
Okay, so we took our robots from last year, and we just wanted to like upgrade them because last year it didn't work, so that's great. And we had some time complications. We expect this competition to be a bit later. So we just upgraded these two top PCBs. And upgraded also our controller. We had some problems with the wheels, they got a little stuck, and also from the light sensors. So that will be our improvements on the next year. Measure them and to improve that. we improved this IR sensor because last year it was like it was seeing the ball like everywhere, every like reflection. So we just made this 3D part to block all of the reflections, and yeah, well.
I see that you have holes in that, very small holes there.
Like here?
No, for the IR sensors.
Yeah, yeah. So we have to drill them out because like it wouldn't see anything.
Uh-huh.
So we just drilled some small holes for the art to see.
And aren't there any dead angles
Well, we want to
when
make
it's
like
small?
the improvement for the next year will be that we'll add more the sensors because like here is 0 and here is 30 because there are 16 of them. So that's our main issue right now. So we'll definitely add some more of them. And also our gyro is kind of out of date because it's MPU and it's like classic Chinese, so it doesn't work so great.
Oh, any questions from the audience? Anyone? If not, then thank you very much. Last but not least, team from the press show.
So we're
Team
Team
Mushrooms.
Mushrooms, and this is our first year on Robocup soccer. We're the first team in our school. I'm pretty sure we're the first team in our city. So we started in September. We had to completely design robots from scratch. We had nothing. So we made 2 custom PCBs. Everything was working fine. But a week and a half before the competition, our 2 Team C 4.1s died. So we had to remove a lot of the capabilities of our robot. For example, we had ultrasonic sensors ready, it's going to work, and gyroscopes. But due to the fact that the Team C died, we didn't have enough pins on the Arduino, and we couldn't order a new Team C in time. Another thing, we have a open MV cam. We use it to sense the colors of the goals, and that's how we try to angle our robot to the goals, but it didn't work too well. There's definitely a lot of things to improve, so hopefully it goes better next year.
This is
I think that's everything. It's not very special compared to our guys.
How do you make the dribble spin?
Oh, it's just connected to plus and minus. There's a motor inside.
Where's the motor?
It's inside the.
Really?
Yep.
How did your team see that? That's like
So, it's a funny story. One fell off the table, and the USB got broken, and another one burned somehow. So,
because we also used a TNC 4.1 when we didn't have any problems.
I have no idea how it worked.
You have to burn through 5 of them for it to work. That's the golden rule.
Also on the bottom PCB we have like line sensors. We use a ATmega 328 to like read the data and put it into a specific form so the Arduino has less work to do basically.
Have you had time to implement different strategies or play
Not
with
really.
strategies?
Like, it's been really tense. We like Team XLC. We thought the competition was in April, so.
Maybe last question from me, like, what do you think, like, you are a new team,
Yeah.
what do you think is, like, most important for new teams? Like, what resources, what do you like, or maybe how would we make your life easier, maybe, like, to start with Robocup or something like that?
Definitely, like, if in the rules document there's like some, I don't know, maybe tutorials or something, because there's basically nothing, like, we just set some specific information, but you have to find everything yourself. And sometimes we couldn't. For example, we didn't know the ball had wavelengths and things, so you could sense the distance. So we didn't implement that. So
One good resource is that we store the posters from the international competition on the GitHub, which you can read and basically get some inspiration there.
you find a lot of inspiration from those. Definitely.
All right, thank you very much. Now, please, we were asked to go out for a photo. So now it's 5 p.m. in the backyard.
Okay.
Okay.